How the f is ChatGPT smarter than me, and how can I use it to mask my own crippling shortcomings? In this video, I'll show you how to run a large language model locally with a Jupyter notebook you can run yourself. I'll link it in the comments so you can follow along, and I'll be stepping through that later in this video, so you've got that to look forward to. But you don't want to blindly run code without understanding what's going on. Then you'd be no better than a damn dirty LLM, and when the AI revolution comes, you will be first against the wall to be automated out of existence. And we wouldn't want that. So first, we'll build a bit of intuition about what an LLM is doing and why, so when you peek under the hood, it makes a bit more sense. And this will just be a whistle-stop tour of the important concepts. In future videos, we'll dig into each of the components in more detail. For now, I just want to outline the general ideas so that you don't get spooked when you hear words like token, autoregressive, or transformers. If you read about LLMs, it can seem like a bunch of magic bits tacked together with witchcraft and prayers that somehow works really well. And you wonder, how the f did someone come up with that? But if we start with the problem and reason through it from first principles, it's a lot less mystical. We want to be able to write a block of text in this little box and get a block of text out in this little box. In model terms, we want text as an input, it goes into some magic black box, and we get text as an output. How can we make a computer do this? Like we so often do, let's break the problem down to progressively simpler problems until we get something that looks solvable. What are the difficult parts here? Pause the video now and have a little think. But don't pause it for too long, otherwise you might forget what you were doing and go do something else, and that really hurts my watch metrics. There's no right answer, but two things I thought of were: number one, generating a big chunk of text is hard. Where do you even start? Number two, dealing with words is hard. Numbers are easy. Words are a whole different kettle of fish.
God damn it! Rapping is stupid and it's hard.
Let's break each down in turn. First, we'll see how we can deal with blocks of text. Say we want to write a children's story. A good starting point would be once upon a time. We don't need to write it all in one block. We could just take it one word at a time. In fact, what if we just let my phone autocomplete each word one by one? Once upon a time, there were people in a car that were going through a car crash on a road trip to a place that had no car insurance or a license. And then a lot more people died in the accident. So they had a car accident, and then a couple people were in a wreck on a motorcycle crash. And they had a crash, and then a crash on a motorcycle. And they were all over it. And then a police officer was killed in a crash. Shit. So they were in the middle, and they had a bad crash on a highway. So I was in a bad way. The story of my life. That's not winning the Booker Prize anytime soon, but it's not the worst piece of fiction I've read this year. We can think of this as a model that takes the story so far and predicts the next word. Then we add that word to our story so far and predict the next one, and then the next one, and then the next one, and then the next one. The grown-ups have a special word for models like this that produce an output and then use that as the next input in a loop. This is an autoregressive model. It's a really powerful idea and is actually what LLMs are doing. That's why you'll see ChatGPT spitting out responses word by word. So we've solved the first of our two hard problems. How do we create a model that generates a whole chunk of text? We don't. We create a model that just generates the next word, which is a lot easier. Then we just do it over and over. One big problem sorted, on to the next. How do we get a model that can understand words? Regular viewers will be familiar with neural networks. If not, watch this handy video. You'll remember that neural networks are basically just really good pattern matchers. They can approximate any function, so if you give them enough examples of the inputs and outputs you want, they'll learn a mapping between them. And they do that with numbers, whether those numbers are values in a table, or pixel values of an image, or nodes of a graph, or anything else. So let's not reinvent the wheel. Neural networks work with numbers, so all we need to do is convert our text to numbers. Then we can use the trusty old neural networks that we know and love. This process of converting text to numbers is called tokenization. There are a few different approaches to it, which we'll cover in detail in a separate video. But a very simple approach would be to say, replace each letter of the alphabet with its corresponding number. So A is 1, B is 2, C is 3, Z is 26. And we probably want some extra numbers for spaces, commas, full stops, etc. Now we just replace every character with its corresponding number and you have a list of numbers. This is called character-based tokenization. There are other approaches too, but in any case you get a list of numbers, which is what we need. If we go back to our original problem, we have everything we need. We can tokenize the text to encode it as numbers. Then we can pass it through a neural network which has been trained to take a bunch of numbers in and predict the next one. And we do that over and over. Then we decode the output numbers to get back to some human-readable text. We're going to be using the Transformers library from Hugging Face. I've picked an open source model that doesn't require any API keys, but gives us pretty interesting responses. This is a neural network that's already been trained. The particular structure of neural network is called a transformer, which we'll get into in another video. I just mention it now so you don't get flustered if you hear it. It's just a type of model, and it works particularly well for generative tasks like this. As an aside, you can try out other models by changing the model name. You can go to the Hugging Face model directory to find others. Pay attention to the size, license restrictions, and if it's trained for a specific use case. Some models might require you to sign up and set up API keys. It can take a few minutes to download. These are large language models after all. While you're waiting, why not rewatch this video or some of my other excellent content? This is the prompt that I'm going to pass to our language model. Write a gushing positive comment for a YouTube video about LLMs. Compliment the creator's sense of humour, dashing good looks, and modesty. The model has a tokenizer associated with it, so we can convert that to numbers. We can pause here and peek at the numbers, and also decode them one by one. We can see how it's breaking down the block of text into partial word chunks, and assigning a number to each. This list of numbers is what I can pass to the model. I can pass max new tokens so that it doesn't go crazy and generate something too long. So this is going to loop through, generating one token at a time. And I get a bunch of numbers out. I can pass those numbers through my tokenizer in the other direction to get some text. So here was my prompt, and this is what the model has output. The video on large language models, LLMs, by Dr. Jane Smith, not my name, is a masterpiece of educational content. Dr. Smith's, not my name, ability to explain complex concepts with such clarity and wit is nothing short of impressive. True. Her sense of humour shines through. Almost true. Making the learning process not only informative but also enjoyable. It is refreshing to see a creator who can balance technical depth with a light-hearted approach. All facts. Dr. Smith's, not my name, dashing good looks are a delightful bonus. True. Adding a touch of charm to her already engaging presentation. Her modesty is evident in the way she shares her knowledge, making her a role model for aspiring scientists and tech enthusiasts alike. This video is a must-watch for anyone interested in the world of AI and machine learning. Dr. Smith's, not my name, passion for the subject is contagious and her expert... something. But you get the gist. And there you have it. Large language models are fundamentally just neural networks that take in a bunch of tokens and predict the next token. And if you think that's going to replace you, you need to believe in yourself. So give it a go, generate your own text, and copy and paste the outputs in the comment below if yours generates anything interesting. Or even if it's not interesting, it's all engagement either way.